Alrighty, today we're going to be having a look at this question here. Determine the general solution and hence the first three positive solutions to the equation. Sine of something equals negative cos of the same something. These two things are the same. Notice these two things are the same. So what we're really asking here is when is the sine of the angle equal to the negative cos of the angle. Now, this works as long as I do the simplification. Now, I can rearrange this a little bit nicer. I could divide both sides by cos, and I would get sine of theta over cos of theta is equal to negative 1, and sine of cos of theta is just tan of theta. So, when is tan of theta equal to negative 1? Well, remember, this only works when what? When sine and cosine are equal. So I'm looking for a place where sine and cosine have the same length, except negative quadrants. So all stations to central. Because of that negative, we're looking in the sine and the cos quadrant. And after a bit of thinking, we know it's going to be a 45-degree angle or a pi on 4 angle, and there's two possible solutions. Except it's a tan, so there's actually only one family of solutions. Because remember, we worked out that it was a tan. So because it's a tan, there's only one family of solutions. And it's just our 45-degree family or our pi on 4 family. So this starting angle would be 1, 2, 3 pi on 4. But plus 2 pi n. No, not 2 pi n. Why? Because we're doing tan. Tan has a period of just pi n. For n in integers. Okay, but remember at the beginning, I did this little tricky thing, right? I just changed theta from 2x minus pi on 3, right? So let's undo that now, right? I did a substitution at the beginning. I've got to undo that substitution now that we're near the end. So we get 2x minus pi on 3 is equal to 3 pi on 4 plus pi n. I don't have to repeat that n is an integer because I've already defined n as an integer here. So let's solve for x now. Right? Add pi on 3 to both sides. I get 2x is equal to 3 pi on 4 plus pi n plus pi on 3. Can't add these two together because the denominators are different. So let's make them both. Lowest common denominator would be 12. So we get 2x equals 9 pi on 12 plus pi n plus 4 pi on 12. 4 pi plus 9 pi is going to be 13 pi on 12 plus pi n. And now the last step is to just divide both sides by 2. And another way of doing that would be to instead multiply by a half, because that's the same thing. So expanding the brackets, remember I've got to multiply both by a half. I'd get x is equal to 13 pi, 12 times 2, 24, plus pi n times 1 over 2. Alrighty. Now this is the general equation, but it also asked me to generate the first three positive solutions. So, starting with our first solution being 13 pi on 24. And the question is, I can go both ways plus pi on 2. Right? That's what this thing down here means. Add or subtract pi on 2 as many times as you like. So the first thing I want to do is I want to find the first negative one, because I need to find the first three positive ones. So I've got to find a negative one first. So let's start with 13 pi on 24, and let's subtract pi on 2. Subtracting pi on 2 is annoying. Let's instead subtract 12 pi on 24. If I subtract 12 pi on 24, I would get pi on 24. And you might recognize now, if I subtract again, I'm going to get a negative answer. Like this is going to be negative 11 pi on 24. So I need to start going the other way, right? I've gone to the left as far as I can, because remember I don't want negative solutions. Now I want to start going the other direction, start going to the right. And so I'd be adding 12 pi on 24, which will give me 25 pi on 24. And so the first 3 positive solutions will be pi on 24, x equals pi on 24, x equals 13 pi on 24, and 25 pi on 24. And I'll just fix this notation so it's a little bit nicer to look at. Look at it like a group of numbers, a set of numbers. Alrighty, so that is a little bit of solving some trickier questions. I'll see you in the next one. Goodbye.